Here's an interesting little device from the 70s or 80s. It's a fluorescent working light with a little flashlight here. And you can switch here. You can switch from one to the other or put it in the middle. And if I recall, it used to be pretty bright. Nothing compared to what we have today, but for the 70s, this was pretty good. Here's a battery compartment. It takes 3 C cells, I believe. And used to give a pretty good light. And it still works very nicely. I haven't used it for a while, but it still works pretty good. And the idea of making a miniature fluorescent light is pretty neat. It doesn't work, doesn't need a ballast. It just needs an oscillator, AC oscillator to with a sufficient voltage to light it up. Well, anyway, we'll take this apart and we will analyze what the circuit, we'll look at the insides and see what it does and do some measurements. I've taken it mostly apart, and there you have the fluorescent bulb, and it's got a mirror behind it. And there's the circuit. It's a type of, I guess, DC to DC or DC to AC circuit. And you've got a transformer, a potentiometer, 2 film capacitors, a transistor, and a resistor. Oh, and one little electrolytic there. I would venture to guess that that is a circuit that is called a blocking oscillator. So I'll go into the theory of a blocking oscillator. Here is not exactly the same circuit, but it's the same idea. Transistor, feedback circuit, and bias. And this gives you the kick to start it. So you turn this on. Here's the battery. Current will flow up here. That'll start the circuit. Then you'll get a current flowing through here. It'll be fed back to here, and that'll sustain the whole operation. This here is your output. It's not necessarily it won't be a sine wave, but I just did that to signify an output. The ratio of this to this will determine the output voltage. If this is bigger, it'll give you a higher voltage. And so I'm going to fire up the circuit and see what type of performance we get. My mistake. It took 3 C batteries, which would be 4.5 volts. And so I'll have to lower the voltage I put into it. There's it set in the flashlight mode. And then let's push it into the, there we are. That's it in the light mode, the working lamp mode. Not very bright, but it probably just needs to be fiddled with. When this is run off batteries, it's much, much brighter. I guess the power supply that I'm using, it's a very small power supply, and it can put a maximum about 500 milliamps. Because I remember the last time I used this device, it was much, much brighter. But anyway, it just shows what this device is capable of doing. Now I will take the fluorescent bulb out and I'll put it on a scope and measure the current that is going to it. So here it's lit, and we're 500 milliamps. And if you can see the waveform there, I'll just light it here, try and get it better. There, that's maybe a bit better. There. It's always hard to focus in on these LED displays here, liquid crystal displays, I should say. Anyway, you can see here that the spikes are just over 200 volts. It's 200 volts per division. And the frequency, it's 39.1 volts RMS. That's 18.4 kilohertz. Now I've removed the fluorescent bulb, and we've got 440 milliamps. 440 milliamps, and very difficult to see. So I'll turn off the light again here. Okay, so now we've got 129 volts RMS. The frequency has gone up to 28,000, and the spikes are over 1,000 volts. So each division is 1 kilovolt. So you can see that you got spikes that are over 1,000 volts that are being developed by that blocking oscillator. Quite interesting. I can see this blocking oscillator is having lots of opportunities, or offering lots of opportunities in projects, because in a little space like that, you can create a device that puts out a good number of watts with this one transistor and a transformer and a couple other. You could use it as to develop high voltage for tube radios or tube equipment, or you could use it in a Geiger counter. Number of applications where you need a higher voltage from a battery voltage, kind of like the old-fashioned vibrators, only in this one you have no moving parts, so it's be extremely dependable. So there it is, a blocking oscillator used to light a fluorescent bulb.